Below is a rewritten description of the Indian Space Research Organization's ISRO journey, without headings, in a narrative style, condensed to approximately 2,500 words as requested. The text maintains the essence of the original, focusing on ISRO's origins, technical achievements, failures, and ambitions, while weaving in the historical and cultural context of India's space program. Due to the constraint of 2,500 words, the narrative is streamlined but retains key details, technical insights, and the spirit of resourcefulness and collaboration that defines ISRO's story. For decades, space exploration seemed like a high-stakes chess match between two superpowers, the United States and the Soviet Union, each vying for supremacy beyond Earth's atmosphere. Their rivalry, fueled by Cold War tensions, dominated headlines with moon landings, orbiting satellites, and interplanetary probes. Yet, as these giants clashed, a quieter but no less ambitious player was emerging from an unexpected corner of the globe. India, a nation grappling with post-independence challenges and limited resources, was laying the foundations of a space program that would eventually rival the best. The Indian Space Research Organization, or ISRO, began its journey in the 1960s, not with sprawling launch complexes or billion-dollar budgets, but with a church, a bicycle, and a relentless drive to innovate. This is the story of how ISRO transformed from a fledgling operation in a rural village to a global space power, achieving feats like landing on the Moon's South Pole and reaching Mars on a shoestring budget, all while remaining under the radar in Western narratives. The story begins in Thumba, a small fishing village in Kerala, just below the magnetic equator location that would prove ideal for launching rockets. In the early 1960s, India was a young nation, its infrastructure modest, its economy stretched thin. The idea of a space program seemed audacious, but a group of visionary scientists saw potential in the skies. They chose Thumba not for its facilities, there were none, but for its unique geographical position, perfect for studying atmospheric phenomena. The only suitable building in the area was a local church, and with the pastor's blessing, it became the unlikely headquarters for India's first space experiments. The scientists, led by pioneers like Vikram Sarabhai, faced logistical hurdles that would seem comical today. Rocket components arrived from across the globe, a sounding rocket from NASA, a sodium payload from France to create glowing orange clouds in the upper atmosphere, and a Soviet computer to track altitude. But the parts didn't always fit. The French used metric measurements, the Americans imperial, and the Indian team found themselves machining components inside a church, surrounded by an explosive sodium payload. Transporting these parts was another challenge. With no dedicated vehicles, scientists often relied on bicycles or ox-drawn carts to ferry equipment from the train station to the launch site. On November 21, 1963, India launched its first sounding rocket, a modest but historic achievement. Across the peninsula, scientists tracked the mission, snapping photos and recording the orange clouds' shifting glow in the sky. In nearby villages, locals marveled at a strange, beautiful sunset, unaware they were witnessing the birth of a space program. This moment marked the beginning of what would become ISRO, a story rooted in ingenuity, international collaboration, and sheer determination. The early days were defined by this makeshift spirit, but the goal was clear: build the capability to launch satellites from Indian soil using homegrown expertise, all without the vast budgets of the Cold War superpowers. India's approach was pragmatic, leaning heavily on partnerships with both sides of the global divide. NASA provided 13 sounding rockets and hands-on training for Indian engineers eager to study the magnetic equator running through southern India. The French licensed their Centaur rocket design, which ISRO initially imported but soon began manufacturing domestically. From the Soviet Union came hundreds of M100-sounding rockets, launched weekly by the mid-1970s. These rockets helped India build better weather models, deepening the understanding of the monsoon cycle critical to the subcontinent's agriculture. With each launch, ISRO expanded its operations. The small church in Thumba grew into a complex with offices and hangars, and the organization gained the confidence to design its own rockets. The Rohini 75, a small rocket weighing just 32 kilograms and standing 1.5 meters tall, was ISRO's first attempt at a homegrown design. Its body was made from off-the-shelf aluminum extrusions, and its fuel was Kadite, a smokeless propellant originally developed to replace gunpowder. Capable of carrying a 1-kilogram payload to 10 kilometers, it was modest but a starting point. Over time, ISRO refined the design, culminating in the Rohini 560, which could lift 90 kilograms to 390 kilometers. These incremental improvements laid the groundwork for more ambitious projects. In 1977, a modified Rohini 560 tested advanced control systems, moving beyond the basic fins and staging of sounding rockets. The test included hydraulic fin adjustments and a novel method called secondary injection thrust vector control (SITVC). Unlike NASA's heavy hydraulic systems for thrust vectoring, SITVC injected strontium perchlorate into the rocket nozzle to create shock waves, redirecting exhaust gases for steering. Originally developed by NASA for nuclear missiles like the Minuteman and Polaris A3, SITVC was simpler, cheaper, and lighter, making it ideal for India's resource-constrained program. The 1977 test was a success, providing critical data for larger rockets. This success paved the way for the Satellite Launch Vehicle (SLV), a 4-stage solid-fuel rocket designed to place small satellites into low Earth orbit. Solid propellants, requiring minimal pre-launch preparation and long-term storage, were a natural choice for ISRO's emerging capabilities. The first SLV launch on August 10, 1979, failed due to a defective valve in the second stage, causing instability and loss of control. Undeterred, ISRO tried again on July 18, 1980, successfully placing the Rohini 1 satellite into orbit. This made India the 6th nation with independent launch capabilities, a remarkable feat for a program built on borrowed technology and ingenuity. However, the SLV's record was mixed, with only 2 of full launches succeeding, prompting ISRO to develop the augmented SLV-ASLV. The ASLV added to strap-on boosters to increase payload capacity and stability, but its early flights were troubled. The first launch in 1987 failed due to asymmetric thrust from the boosters, and the second in 1988 lost control during booster separation. After 1 partial failure and 1 success, ISRO recognized the need for a more robust solution. Parallel to its rocket development, ISRO invested in satellite technology, with one of its most ambitious early projects being the Satellite Instructional Television Experiment Site. Launched in 1969 in partnership with NASA, SITE used the ATS-6 satellite to beam educational programming on agriculture, health, and literacy to over 2,400 rural Indian villages. Engineers built a 10-meter parabolic antenna in Ahmedabad to uplink content, which was then broadcast to low-cost TV sets powered by solar stations in villages without electricity. The programs delivered critical information on farming techniques, disease prevention, and nutrition, boosting school attendance and galvanizing rural support for the space program. Arthur C. Clarke called it the greatest communications experiment in history, and it showcased ISRO's commitment to using space technology for nation building.